why does cos x equals negative sine x when it's derived? That's probably why you clicked on this video, and I will show you why. I don't know why else you would be clicking on this video, but anyway, just like it's very similar to how we did sine x. When you derive it becomes cos x, and I'll be using techniques from that video and the past two videos. Okay, so the long way. Limits as h approaches 0 of cos x. Now, if you watch my other videos, you would know that h is equal to delta x, which is the change in x. And you should watch the other videos because I will use techniques in this video from those videos. Okay, anyway, let's get to it. The limit as h approaches 0. The formula for limits is fx plus h minus fx over h. Okay, basically with this bit here, we replace the x with an x plus h. And this bit, we leave it because there's only an x and there's only an x here. I will write that down and show you what I mean, so it doesn't sound like complete gibberish. We leave the function the same, which is cos, but we change the variable to x plus h for the first bit, and we subtract the function and the variable being x. You see how these look very similar? Yeah. Okay, so now we have this. There's like a trigonometric identity which basically tells you what cos of x plus h equals. You're not deriving or anything, it's just another way of showing this. In textbooks it'll probably look like cos x plus y, but the same principle applies. Okay, so we rewrite limits as h approaches 0, always write that. And this little bit here, I'm going to rewrite. Okay, it's going to look like cos x multiplied by cos h. Subtract sine x multiplied by sine h minus cos x. I'm only putting the minus cos x down here because I can't fit it on the top. But this big much here is the same as that. It's just another way of writing it. And you're probably thinking, why would you want to write that? It's extra long. Just creating more work, but you know, it's not really. It's gonna help solve this. So, limits as h approaches 0. How would we do the next step? Well, one way of thinking about it is we have cos x, cos h, a cos x, and we have a sin x and a sin h. So it might be easier to split the fraction and put the coses on one side and the sines on the other, which is what we're going to do. So we have cos x multiplied by cos h, subtract cos x all over h, and then we're going to subtract sine x multiplied by sine h. Oh, I can't fit that in. Over h. Well, I said it, so you should be able to know what that scribble is. Anyway, so what's the next step? Here we have a cos x and a cos x on either side of the subtraction. If you think about it, we can factor it out. And if we factor it out, what it tends to look like, what it does look like, is cos x, in brackets, cos h minus 1 over h. Essentially, if we were to expand these brackets and multiply the cos x back in, it would look like this. If you've watched my other videos, you might know where this is going. But now we're going to subtract sine x multiplied by sine h over h. We have a bit more room, so it's a bit clearer. Almost done. So what happens now? Well, what I'm going to do is I'm going to pull away this cos x from this fraction, and I'm going to pull away the sin x from this fraction. And so I'm leaving everything with a h grouped together. So we have cos x multiplied to cos h minus 1 over h minus sin x multiplied by sin h. I'll put a multiplication sign there, but sin h over h. These two are the exact same, by the way. Don't get confused, because we're still multiplying cos x onto this, and cos x is multiplied onto this. Same with here. We're just making it look different. Most of this is just making everything look different and changing how things look in order to solve. But anyway, so what can we do with this? Well, in another video, I showed that cos h minus 1 over h as h approaches 0, which means as these numbers tend to 0, so they're not quite 0, but they basically are. It means, I did that wrong, that equals 0, and sin h over h as h approaches 0 equals 1. One way I like to test this is I grab my calculator, because I can't quite imagine it. I grab my calculator and I type this in, cos h minus 1 over h, and I just put 0.001, just a very small number, and just see what the outcome is. And if it's very close to 0, or if I did this and it turns out to be very close to 1, then I know it's correct. But you need to remember your calculator needs to be in radians, because if it's not in radians, it'll probably spit out a weird number. Anyway, so that equals 0, and that equals 1. So what we're left with is limits as h approaches 0. We have cos x multiplied by 0 minus sin x multiplied by 1. Now what does this mean? Well, anything multiplied by 0 is cancelled. Anything multiplied by 1 is just what it is. So the limit as h approaches 0 is negative sin x. And so the limit as h approaches 0 of cos x is negative sin x, which says the derivative of cos x is negative sin x. Thank you for watching. I hope you learned something.